we're starting from here. Go.
Good afternoon, everyone. It's great to see you all here. Thank you for joining Inovenso's first live broadcast. My name is Bishra. I'm working as an international sales specialist at Inovenso, and
my name is Umar. I am the R&D engineer here at Inovenso. And my background is in physics and specialization with nanotechnology.
Today we will talk about the basics of electrospinning. We are here to give you information about electrospinning and electrospraying technology. Firstly, we will look at the basics of electrospinning technology. And then we will discuss the process from polymeric solution preparation to the nanofiber production. And then we will learn post-treatment and characterization methods. And then finally, we will address all of your questions. Please, if you have any questions, type in the chat section on YouTube, or please reach out to us in Instagram account so we will address them at the end. Before we begin our program, I would like to inform you about Inovenso, who we are and what we are doing. So we offer a wide range of electrospinning and nanotechnology devices mainly related to nanofiber production. We have a broad range of application areas from industrial to laboratory, using patented technology, hybrid technology, and my colleague Umar will explain deeply about our technology later on.
Thank you, Bushra.
You're welcome.
I'll just take it from here. All right. So my colleague Bushra explained you the specifics of what we're going to do. So if we can get a presentation running so that we can talk about the rudimentary topics of electrospinning, just to give you an introduction. Afterwards, we will be showing you the actual thing with our laboratory device. If you can see the slide over there, Intro to Inovenso, is just to give you an idea of the type of science that we are doing in our laboratory. So nanofibers, I'm sure you are well aware of, are these very small form of nanoparticles or nanomaterials, rather, or as long cylindrical bodies. So if you can see in the picture right there that it's much smaller to the average human hair. So yeah, and these are used in various applications and various basic industries. So moving on, electrohydrodynamic process. So electrospinning and electrospraying are a form of electrohydrodynamic process. Now to make it simplified, it actually is basically the study of charged particles moving, rather, in fluid format. So it's a way to fabricate nanoparticles or nanofibers. So our machines are capable of both of these, so we can move on to the next slide. Okay. So yeah, this is what you get. This is the material that we are made of, that we're making from our machines. So polymeric nanofibers in SEM image, you can see here. So moving on to the next slide. Okay, yeah. So electrospinning is essentially when you have a polymeric solution and you are inducing high charge onto it. The charge accumulates and causes the solution to be, of course, charged and unstable. And a charge is basically emits into a spray. Now that spray emits light in the air and it starts solidifying onto the collector. So the end product of this is the nanofiber, or rather a mesh of nanofibers, as you can see in an SEM image. So we can move on to the next slide. So yeah, electrospraying is essentially very similar. They're sister processes. But the only difference is, the crucial difference is rather, that you don't get nanofibers, which are small cylindrical bodies. You get nanoparticles. So yeah, we can move on from it. Yeah, so I would like to mention that all of these processes incorporate high voltage, as told by the commission. So it's basically, the machines have high voltage, high tons of range, and they're all being used. So next slide, please. So yeah. So just one couple of dictionaries, I guess you say, some words that you would need to know before we move on. The Spinneret, starting with it. So that's where we charge the solution, where the solution is being fed and high voltage is being incorporated. That's where the jets are being formed into. Now, a spinner could be a nozzle, it could be a roller, it could be anything where the jets come out of, essentially. So, moving on. Okay, another important dictionary word, I guess you would say, for electrospinning is the deposition area. This means the collector where it's being deposited onto. Now, normally it's either neutrally charged or it's polar charged, but essentially that is the end destination of the jets or the nanofibers that are being formed for this process. Moving on. Yeah. So apply voltage. Yeah. So there's a voltage in between the electrodes, the spinneret and the collector or deposition area, and it basically allows the solution. This makes the trajectory go into a specified direction because of opposing charges, or rather, it could be charged from the spinneret and the collector could be grounded. In any case, in both cases, rather, there's a potential difference, and the charge has a formed path that it needs to go to, essentially. Moving on. Another important thing, parameter that you should know about electrospinning, of course, is the flow rate. So it's very imperative that the flow rate is being fed at the appropriate amount. Otherwise, it would not form proper jets or it would spill. So it's an important parameter. It's basically the amount of solution you are feeding into your system. Moving on. Okay, of course, the third and I guess the one of the other important fundamental parameters of electrospinning is the needle to collector distance. It's the spinning distance. So what it means is how far are the two electrodes, namely the spinneret or the nozzles with the collector, how far are they apart? Now that is what helps, rather determines the nanofiber morphology, how thin it can be or whatever. So moving on to the next slide. Yeah, so essentially this was it. This is all the basic, let's say, background I wanted to give you before showing the process. Okay, so hopefully that was clear for you. If not, please feel free to ask questions in the chat and we will address them shortly. But now I would like to take your attention to the machine itself. This beauty is the NS24 laboratory machine. Now this one is basically our most advanced setup for the machine. So it has many features, which all of which I'll show you soon. So it's chamber. We prepared this for you, all of it. But before that, I would like to tell you how we prepared the polymer solutions. So if you can see from in our laboratory here, it's if we use essentially pellets and we put them in a solvent that makes it dissolve, solution. We use a magnetic stirrer, so it's basically a magnet that stirs at a particular specified temperature, so that the solution will be dissolved. So this is how we are producing polymeric solutions. But for the purpose of this demonstration, we've already prepared a ready-made sample for you that we're going to show you. So yeah, but before that, I'd like to tell you about the basics, or rather the components of the machine. This is where the spinneret is going to be. It's the anode, scientifically speaking, and this is the hybrid nozzle system. As my colleague mentioned prior, this is our special unique design, nozzle that incorporates low fiber diameter with 4 or 5 times higher production throughput. So it's one of the intriguing features we have in our devices. So I'll just put it here, okay, with the nozzle latched on top, as you can see. Before going further, I'd like to mention, for the purpose of this process or this demonstration, we're going to show you the drum collector. Now, I've already taken the liberty to put in the aluminum foil right here. This is where, so that I can, scratch it out and show you to you after the process. But before that, I would like to inform you that there are other types of collectors that you can use with this machine. Now, some of our clients also wanted to use tissue engineering or like basically make artificial blood vessels for not just basically flat membranes. So for that, you need the mill shaft, which can be connected onto here. Okay, you can plug it on top right here. So this helps you produce tubular structures of nanofibers. But as I said earlier, we're gonna show the drum for this demonstration. Alternatively, if you want a flat collector, this is also possible to put in the machine. But this is for random, or let's say if you don't want the nanofibers to be aligned, it's for that mesh. You can place it similarly, and it'll produce nanofibers on top. So that. Also, I should mention that although we're using the hybrid nozzle, you can also use varying diameter nozzles or needle spinnings, whatever you would like. This is, I believe, 25 gauge. You can find more gauges we can offer you. Other than that, I also would like to turn your attention to this big nozzle. This is the coaxial nozzle. It can be attached similarly, but it has two inlets, one here and one here. Now this nozzle is for the purpose of producing composite nanofibers. So suppose that you want two different solutions being spread. It will basically produce a fiber within another fiber, essentially. But yeah, so this is one other thing that you can use in our machine. Yeah, so I think that's most of it. Yeah, all of it. You have also the standard needle that you can use for this machine. You can place it up here. It can work just as well. But let's just continue and set up the machine. Okay. So I'm gonna use polyethylene tubing that's gonna be connected to the syringe. 1 second. I'm gonna place it into the syringe pump system, so that it can feed the solution into the system at a particular rate. Okay, so it's going to be attached up here. Now, essentially, what I've done is I've made a channel for the syringe pump all the way to go to the nozzle. Okay, so I think, yeah, we're set. We're ready to start our electrospinning experiment. Like we mentioned earlier, high voltage is key, but since it's one of the most dangerous ones, we're gonna run it at the end start. But since we're using a drum collector, we're gonna go to the collector option here, which you can like appropriate a particular RPM or whatever, or homogeneity, and you can associate what distance it will be. So let's go to the distance. Okay, so since I'm using nozzle, I have to press the nozzle mode. Okay. Also, since I'm using drum, I have to press the drum mode so that it appropriates the spinning distance accordingly, so that this from the tip of the nozzle to the face of the substrate is accurate. Okay, so it's gonna be 15 centimeters. We're using a PVDF here, so let's move. All right, so we have to put in the syringe pump. What type of syringe pump? Now you can use various kinds of syringe pumps in our devices, in our machine, but you have to set them accordingly. Now we're using a local brand set 10, so I'm gonna press set 10 here. All right. Also, you need to put in how much solution volume you put. I put 10, so it's complete, full. Okay. Now I'm setting the flow rate to be 5 milliliter per hour. Okay. But before that, I would like to purge the solution all the way from here to the tip. So to do that, I'm going to press. And now the syringe pump is activated. It's pushing the solution all the way to the tip of the nozzle. Okay. Okay, now you can see it's leaking. It's out in the tip. Okay, great. Now, let me just start the spinning, the flow rate. Now it's pushing out 5 milliliter per hour at a constant rate. Now we can apply high voltage to begin the spinning. It's going to be 40 kilovolts we're going to put. Okay, now the process has begun. Right now I haven't activated this drum yet, but I will do so. But I want you to see the jets that are being formed. They're being hybridized and they're much more common, or much more, let's say, multi-jet emission compared to the standard. And I'm not sure if you can see, but it's they're nanofibers being formed. So let's turn to the collector. Let's activate the rotation, and now, as nanofibers are being deposited onto the drum, it's rotating, allowing more aligned patterns. Okay, so now it's aligning and the process is continuing. In addition to that, our machine has a homogeneity system. So what we were saying is that it has a uniaxial motion from the collector. Okay, this will incorporate a more even spread of the nanofibers onto the substrate. So let's go ahead and activate that. Okay. So while the machine is rotating, it is also moving the collector rather, moving left and right to and fro, and that allows the jets to deposit more evenly. Okay, so let's see if we can get a good image of this, the process. You can see about 2 or 3 jets that are being formed. Again, this is basically a multi-jet electrospinning system. The normal standard needle wouldn't allow such necessarily that much. But yeah, this is for high throughput essentially, while it's maintaining let's say very low fiber diameter. So yeah, this is the basics we covered basically. The spinning, or rather the spinning distance, the rotation of the drum, the electrospun thing, okay? And also I'd like to mention that some polymers can't really work. They're sensitive to the atmosphere. So in those cases, what you would need is a temperature controller, which can be installed with this machine. We produce those, and the dehumidifier to affect the ambience temperature and the humidification, excuse me, the relative humidity, so that the nanofibers would spin, let's say, more efficiently. So yes, so this is basically our process. This is the electrospinning process. Like I said, atmosphere, of course, fan, all this. Okay, and once this process is over, we can take this aluminum foil out. I'm going to show you what's the end result, so that you can get a better idea of what just happened here. Yes. So yeah.
So we are reading your comments and your questions. We will address them at the end of our session. Please just write down whatever you have in your mind, so we will just answer them all.
Yeah. Yeah. So just to recap, there's a charged part of anode here, and there is a potential difference, like we discussed in the presentation. I should mention that the grounded electrode is basically, this is grounded, so it's positive to 0, and that's what's allowing the jet to go upwards rather. This is what's helping it to continue forward. Yeah. So this is basically our process. Let's see. Mm, 1 second. Let's increase the RPM to make it more. So yeah, now you can increase the RPM up to maximum 2000. There are other parameters you can affect, like suppose that it's just the spinning distance is too small, the solution is leaking. You can also increase that manually from here. Or for yeah yeah. So I think this basically covers what we were going to discuss today. Yeah, I should mention that since we're dealing with high voltages, there are some safety features. Okay. Um, excuse me. Safety features of the machine. Now, in case that you need to turn off the voltage supply, you need to turn off the machine entirely, you need to press the emergency stop button. Okay, and this should cut the voltage supply of the machine. Okay. Um, in other cases, now also another thing is that when you're electrospinning, the solvent is being vaporized, it's being evaporated into the chamber. So for such a thing, you need a ventilation device. Luckily, our fan has an exhaust fan at the end. Our machine has an exhaust fan at the top. what it does, it exudes all of the solvent in the chamber all the way outside into your ventilation shaft. So to remove, the solvent from accumulating, rather. Let's see if we can play around a little more. Like what else we can do with this. Mm, all right. Yeah. Okay. So yeah. So this is basically drum collecting. Also, there's a safe door feature. I'm not gonna close the door right now, so that I want you guys to have a better look of the process. But the safe door feature, what it does is under the event that somebody comes to the lab and opens it during the process, you can activate this safety feature in which the solution, or rather the spinning process, stops. It goes to a halt. Now that is some other feature that we have in this machine that allows better, better control over the parameter and the process. Yeah, so yes, also in the chamber we have a temperature and a humidifying sensor. It tells you basically what it does, the temperature and the humidity of the process happening. So yeah, this covers essential process. All right, and yeah, I guess this is the core essential of electrospinning. For the NS24, also in certain cases, where you want to do gas-assisted electrospinning. Now, say you're dealing with pesky polymers like hyaluronic acid, for example. So, what you can do is from the side of the machine, we have basically a channel, a gas channel that allows you to, from your gas canister of the laboratory, you can incorporate inert gas like nitrogen gas, and that gas can be used with the coaxial system. So what you do is you can feed gas into one nozzle and a solution from up here. And so what will wind up happening is while it's spinning, gas will help push it upwards, help its trajectory, so to speak. And that way there will be better spinning. But this is for those electrolytic polymers, some that you have problem with, the sensitive. So our machines do such things in case of pesky polymers like hyaluronic acid. So yeah.
And right now, we will focus on post-treatment and characterization methods. So we will show you what we have produced so far. My colleague Ömer will actually stop the machine, and then he's going to give me the sample which we have produced so far. So it will be helpful for you to see what Inovenso produced.
Okay. So all right. So let's see. I think it's enough time that we gave the electrospinning process. We can stop it now. So we can just press pause. Okay. This will cut the voltage and the spinning and the rotation, everything. So yeah, let's take out the sample and let's show it to you.
I can't help for sure.
Okay. Okay. So a little bit difficult here. Oh, okay. So let's see if we can get a better view of this. So can you see the sample here? There is a small layer of PVDF nanofiber layer that latched onto this aluminum foil. So let me show you. So you can see that these layers are being formed. So these can be post-processed. Now, there's some, in our past experience what we had is with the nanofibers, you would like to have post-treatment, or rather, you would like to have nanoparticles incorporated. So we also, what we do is we basically fill the solution with nanoparticles like, is this better? Okay, good. So we fill the solution like with silver particles to incorporate an antimicrobial layer, or you would want to use VOC, let's see, VOC compound, you know, as you can see it. All right. VOC anti agents so that you can help what you call it. You should incorporate a odor adsorbent. This is actually for filters in the sense that it helps give deals with bacteria, viruses, and helps absorb. Yeah. So yeah, it helps with basically absorption for such. So you can add properties, add composites. Okay. I want to know if you guys are seeing this properly. Okay. Maybe my colleague was ready to.
Yes, here you can see a better image. Since we have started machine for a little bit of time, of course, it might not be obvious that much, but you can see there is a line here, a bit, and you will see it right there. And right now, we will focus on our actually processes. And as Umar is going to show you, this is the end of the nanofiber production material.
So I'd like to mention that we were showing you the sample with aluminum foil, but our machines can be used with basically non-woven textiles, like such as these. Now, this large sample you see here, this is for our pilot line. So certainly, this pilot line is, you can see it's a roll-to-roll collector. So it's being latched on here. You can see. Pardon the technical difficulty, folks. Yeah. So this is the roll that I believe this is PET, polyethylene terephthalate, and we spun nanofiber coatings onto it, on top of it for large scale production. Now this large scale production is basically for the production of nanofiber masks or HEPA ultrafiltration based on the client's requirements. But these help because they have excellent porosity and excellent fiber diameter. It allows proper transmission of clean air rather. So they're really high in demand in the filtration industry. So we're getting a lot of demand with large scale nanofiber. Yeah, sure.
Yes, we can.
Yeah. So again, if you just rub it, you can see that the layers of nanofibers are coming off. So yeah. This is for filtration. But like we mentioned earlier, that it depends on what polymer you're going to use, what recipes you are going to use. Other than filtration,
this is also N99 and 95 material, which also you can use it for mass production and filtration as well.
All right. So yeah, this like we mentioned filtration, but I would also mention that not just filtration, we can also use for biomedical applications. Like I mentioned before, the tubular structure it helped us make blood vessels, artificial blood vessels that you can remove. Or alternatively, you can for drug delivery systems we had also for wound patching. These are other like biomedical and filtration, I would say, are the biggest industries for electrospun nanofibers. Alternatively, there are others like for energy. So we've had people approach us to help them with solid state battery applications. To produce the separator with nanofibers, solid state nanofibers. And there are quite other interesting ones that we had too. So there are many range of applications for nanofibers. So I guess this is the basics of what we're gonna cover today.
Yes. And now we are gonna go to YouTube section and we will answer all of your questions. We will just begin right now.
Let's see.
Okay. So basically, we are going to answer the first question by from Rajul Islam. How can we adjust homogeneity?
You can adjust homogeneity with the x-axial, the uniaxial motion, right, in the machine. So when the spraying is occurring, like when you have electrospinning from the jet, it's very crucial that the collector is moving to and fro, like we mentioned earlier. It should have a stroke speed, like how much distance it's going and at what rate is it going back and forth, so that the jets properly latch periodically onto the collector, enabling homogenization. I hope this answers your question.
Yes. So thank you very much for your kind comments. We really appreciate your precious words. We really appreciate that. So our second question is that uh, so informative content. Can we use it for class, open for public use?
I'm sorry, could you repeat that?
Yes, sure. Can we use it for classes, open for public use? Can we use our machine?
Yeah, machines, these machines are laboratory devices. They can be used for experimental purposes, and they can be for educational purposes. They help, to get a better idea of electricity. Yeah. So, are there any other questions? Because I would like to show some interesting works.
Of course, you can show it, and then we can just go on.
All right. So this is the blood vessels we were talking about, the artificial, blood vessels we made from the tubular structure. You can see that these are tubular structured nanofibers that we made from the mill shaft, as I showed you at the start of the experimental trial. And these are the N99, N95 masks. So what they have, they're basically PET substrates, and inside these substrates you have your nanofiber layer. It's a very small nanofiber micron, so it's like about 0.6 or 0.8 GSM, and that is basically enough to incorporate high filtration efficiency while maintaining minimum pressure drop. So yeah, but the reason for polyethylene terephthalate is because we need to have a support layer onto the mask. So this is something we have. Is there any other question, Michelle?
Yes. Okay.
Is there any other question, Michelle?
Yeah, we will continue. If you would like to show another.
Okay, I guess we can show this too. This is we're working with the company for this. It's cosmetic mask. So what happens is we made a mask layer rather, which allows basically, but it's cosmetic. It allows a release of nutrients that enter the pores of your skin, and it helps basically improve your face. Basically.
We can open it and show it to you so you can see it clearly.
Sure. So this also incorporates a thin nanofiber layer onto a substrate. You just have to peel it off and.
Let me show you clearly. This side. Here. As you can see, this is cosmetic mask. And here. And I can just open it for you. Just a moment. So you will see details here.
Sure. Let me see.
Yeah, thank you. Thank you very much. Yeah, here. Here you will see a nanofiber in between.
Okay, so you can just take it out and place it on your face,
Yeah.
as such. Okay? So what you're supposed to do is put this on your face. These are the nanofiber layers, okay? Inside. They latch onto your skin, okay? And you basically rinse it off with water, and it basically acts as a cosmetic mask. Okay.
Yeah. So thank you for explaining detailing, Omar. So we will move on to another question. Omar, can you measure thickness in real time and stop spinning when a desired thickness is achieved?
Can you measure thickness
in real time?
No, it's not necessary. You need to measure thickness for a long time, basically, for post-processing.
Yeah.
Mm-hmm.
Okay. So we are having a lot of questions right now. We will try to answer them all, but we're having our best to do. Mm-hmm. Okay. So have you ever operated the tool under sterile conditions? You know why I'm asking. So
yes, we have.
Of course, we have. Do you have an estimated cost per meter for an FFP2 application? So, Mr. Gary, actually, for this kind of questions, please just send us an email so we will answer all of your questions in detail, because price matters are discussed internally. So basically, for other questions is that is there any way to recover the solvents in the cabin for PE300?
For solvents, okay, so once they're used into the system, right, once they're being filled in a jar, consider them already basically in the solution. So yeah, so as for recovering, if you mean that they're getting evaporated in the chamber, there's no proper way to recover them. Mm-hmm. But for like if they're not used, this polymeric solution will still remain to be used for another time.
Okay.
Mm-hmm.
So another question is that, is there any way to cool down the cabin air that is coming out of in order to recover it and push the air to cooling machine and recover the solution, the solvent.
Could you repeat that?
Of course. Is there any way, the last one, is there any way to recover it?
Is there any way to cool down the cabin air that is coming out in order to recover and push the air to a cooling machine and recover the solvents? I'm not familiar with this question. So I mean, this is not something normal for what we can do with our machines. My guess is no.
Okay. So I guess we have answered pretty much all of your questions. Sorry,
Great.
Dan.
Oops.
Yes. So we are gonna go to another one.
Can I see them?
Of course.
Let's see where to go. Okay, Jacqueline Cruz asks, which are the most common biopolymers, eco-friendly and sustainable, that you've used to create nanofibers? Great question, Jacqueline. So biopolymers, among them we've worked with PCL in the past. We've worked with PHB. We have some knowledge of PC, chitosan, and cellulose acetate. So we've actually had worked with a lot of biopolymeric, polymer solutions. So yes, let's see if there's any.
Please ask all of your questions because we're here to answer all of your questions regarding to electrospinning technology and our machines, of course. Please ask us, and we will happy to answer them all. We will be waiting for your questions, and it will be an informative session for all of you who wants to know more about electrospinning system and our machines for sure. We will be happy to answer all of your questions.
Okay. All right. So Anthony Sabini actually has a good point. One has to consider the solutions are quite concentrated, so much the solvent is not required at all. So yeah. So that's one of the key process measures that you have to use with electrospinning. You're supposed to have trials with various concentrations of solvents, and you can find them in the literature of the types of solvents that you can use. So and the amount, like the weight percentage and all of that. So it's imperative even for us to conserve solvents. It's very important. So it's important that you do your research. Yes, this is this PDF right here. Yeah. So viscosity also is an important parameter. So increasing the concentration. Let me see. Can you see it? Okay, yeah. So increasing the concentration increases the viscosity, and that may help your solution electrospin, or it may not. So it's important for trial and error. So yeah. Another one I guess is this one we can show you. It's recently made. That's why it's pretty hot. PHB. This is the biopolymer that we're talking about, the eco-friendly one. We're going to use this for further experimentation as well. You can see how viscous it is. So you're going to be dealing with a lot of viscous polymers, and you have to vary them. Okay, so let's see another question.
Okay, is this machine in NS1 lab?
No, this is the NS24. This is an advanced lab setup. It has much more features than the NS1. It incorporates namely a gas cabinet here, a gas chamber, as rotational collector. You have the chance to add additional modules like the temperature sensor, the temperature controller, and the dehumidifier to control the ambience, and much more, many more.
Yes, another question is that what RC and RCA ranges you can handle?
Okay, so for the NS24, granted if there is a temperature controller there, you can go up to 20 to 40 or 50 degrees Celsius for the temperature. As for the relative humidity, it varies. It goes up to perhaps 60 from 20 to 80 maybe or 90. Yeah.
Let's see what we have.
Is there any?
Yes, I believe we have some more.
Mm-hmm.
Okay. Let's go here. Just a moment. Okay. Do you know the max current that the tool can supply?
Okay, so for the NS24, it's about 40 kilovolts max, and it incorporate with low current. So it's like 0.125 milliampere. You can actually see it there in the machine. So while the process is going, it'll show you how much current is being flowed into the system while electrospinning happens. So yeah, it's very small, 0.125 milliampere.
Yeah. So another question is that although it's a bit dangerous, could you try to focus a laser pointer just above the tailor cone so we can see the jet?
Let's see. Can we? Let's see. Sort of. Although a bit different.
Actually, we have a video in our YouTube channel.
Yeah.
So if you go over our channel, you will see that we have posted a lot of videos, a lot of informative sections. So you can just go over and watch them.
Yeah. So Anthony, I understand it's maybe difficult to show you the jet, but there are various videos you can see on our website that can basically give you a better, much more detailed jet emission than what we showed you.
Exactly.
Let's see another question.
Let's see. Thank you very much. You are supporting us very well, and we are so happy about your comments.
Oh, thank you.
Please ask us about all of your questions. So, can you speak more about the multi-jet nozzle versus single jet nozzle?
Okay. Well,
This is Mark.
Okay, great question, Mark. So, like I mentioned earlier, our hybrid nozzle design system, it basically allows many jet emissions from the solution all the way up to the collector. So it's different from the needle collector in the sense that needle collector gives you, in most cases, one certain jet upwards. But our hybrid system has multiple jets streaming out of the nozzle because of its reservoir design at the bottom. So what does that curtail? That curtails about, it basically curtails that there's going to be many high production rates, like much more, like 4 times than the average nozzle. So yeah, this is basically it.
Yeah.
Okay, you can see it here. We have a raw of this, and you can see there's 6 nozzles, hybrid nozzles. So you can see that it just adds up and multiplies, and you get a very high throughput of nanofibers from this tool.
Okay. So actually, we will schedule another session about nanofibers and their applications in biomedical. So be aware that next week we will have a second session, and we are going to wait you to join our live session, so we will be happy. So another question is that, is it possible to spin under ISO 5 or 7 conditions to prevent particulates during sample processing?
Francisco Chaparro asked this. I'm not too certain what you're asking, Francisco. If you could be more clear with your question. ISO 5 or 7 conditions, or are you talking about the international standards?
Yeah.
Okay, let's move on to another question.
Mm-hmm. So let's begin. If you give us more information, Francisco, we will be happy to answer it.
Okay, let's see.
We are just looking for another question. Okay. So let's see. Actually, you have asked that will this live session be available as a video later? Of course, you will have it in our YouTube channel. We will just share it, and you can watch it overall again. So no worries, you will have these information in our channel. Mm-hmm. So Francisco said yes to your question.
Okay, but yeah. So moving on. Okay. Oh, Maya says I have connected the NS machine to an extraction solvent and it works. Oh, great! Thanks for the information, Maya. Let's see. Moving on. Yeah.
Okay. So Francisco, maybe if you can send us an email about your question, we will just answer it deeply, because we're not sure if we understood you correctly, so we will be waiting for your email.
So Gary Lipson actually asks a very interesting question. Has your materials received NIOSH approval or masks and or FDA approval for medical masks? Yes. So we've taken the liberty to send our masks for testing for both the EN standard, the EN 143 and 149, and for the N99, N95 testing standard. So we've actually achieved very high filtration efficiency, like over 99%. So we can provide more information regarding that if you contact us more further.
Yeah.
Okay.
Let's see if we have another question.
Okay, this is interesting. Young Teo, I believe he's from the famous Electrospinning. Thank you for joining our live stream today. So, what stray electrospun fibers get adhered to the machine wall? Very excellent question, Leon. So, yeah, it's important that the machine has proper grounding. Now, if there is no grounding, what you will certainly find is that the spun fibers will start like going everywhere, like perhaps going at the back of the machine. Now, this is especially for the case for the hybrid nozzle in the situation where the collector isn't grounded properly, or in situation where the spinning distance is high. Now, normally because there's such like many number of deaths onto the nozzle, there's a high chance that it could spin backwards. But that's why you need to minimize the spinning distance. And as long as the machine is grounded, you will not face such an issue. So yeah, let's move on.
Yes, let me open it. Okay. Okay, so another question, let's see. So Francisco is going to send us me an email, so we will answer his question.
Okay.
Privately. So
Right.
yeah. So far, so good. Actually, we have received and answered all of your questions. Thank you for joining our live session. If you have more questions, please take notes, and we will answer them in our second session, which is going to be next week. And then we are going to talk about more of our technology. So thank you so much for joining our live broadcast, and we will be happy to have you all here.
Mm-hmm.
Have a lovely day, stay safe, and stay happy.
Thank you so much.
Thank you so much.
Bye bye.
Bye-bye.